All right, this is 8.3 topic question number 8. We have a small mass with a positive charge at an angle theta when it's in the presence of an electric field. The question presents two situations. It tells you what's happening on Earth, and then it asks what has to happen for this same situation to be set up on the moon where gravity's less. So the first thing is we're told that there's an electric field. If this charge, positive charge, is being pushed that way, then hopefully you can tell that that's enough information for you to go, oh, the electric field must be going this way. Okay? And that's supposed to be a horizontal line. Let me try that again. There you go. Whoops. First time I'm trying this. There we go. Horizontal line that way. So on Earth, something must be happening. You know, how is this hanging like that on Earth? Well, we go back to mechanics and we draw a free body diagram because it's at an angle, and we know that if that's the object, we know there's a tension force this way. We know that gravity on Earth is pulling down that way, and because there's an electric field, there must be an electric force pushing that way. And this is an angle theta, which means if we look at the components, it means that this part of the tension force, that vertical part, T in the y direction and T in the x direction, are functions of T and theta. So T, y, so here's theta up here. So Ty is going to be T cosine theta, and Tx is going to be T sine theta. And since this thing is just hanging there, we know that for this thing to be in static equilibrium, so it's not moving and it's not accelerating, then these two have to be equal and these two have to be equal. Okay, so the first gotcha here, or mechanics recall, is when you've got cosine and sine, the trig alarm should go off. And you go, wait a minute, that looks familiar. If I do Tx over Ty, I get T sine theta over T cosine theta. Those cancel and you get tangent of theta. But since that's just Tx and Ty, then Tx has to be that electric force, and Fg on Earth, right, on Earth, that's just little m g. Okay, on the moon, what has to happen? So we've got an expression for tan theta equals that. On the moon, if you followed that derivation for Earth, the same situation has to happen. The only thing that's different on the moon is this Fg value is different. So on the moon, we have the same free body diagram, but the only thing that's different is that on the moon, that's going to be 1/6 of Fg on Earth, right? Fg on Earth is mg. So where g, right, is the acceleration due to gravity on Earth, and on the moon, the acceleration due to gravity on the moon is 1/6 of that. So that's where that 1/6 comes from. So that's Fg on the moon. Well, the same configuration has to hold. So the tangent of theta has to equal the electric force. That doesn't really change. Over 1/6 mg. So how can we take this guy and have it equal this? Well, that tangent theta has got to be 6 times Fe over mg, which is that guy. So we need to come up with a combination. The answer is whatever combination of changes, either to the electric field or the mass, so that the net effect of those is to multiply is 6, right? So For example, now I'm not looking down at the multiple choice options, but so I'm just trying this. For example, if we increase the charge, right? So if we change, if we go from plus Q to plus 3Q, if we replace the amount of charge on that guy and we triple it, so if we increase it, not replace, but if we increase it to 3 times, then that's going to be 3 times this, right? Because this is going to be 3Fe. If we double the mass, or sorry, if we cut the mass in half, so if we go half the mass, then that's going to do what? I've got mass at the bottom, so that's going to double, right? We've got half mg. That's going to be 2. Well, this is 1 over. So the effect of halving mg is going to be doubling mg. So if we do these two things, triple the charge and cut the mass in half, then if we take those values and do the analysis again, it should be 6 times. So that's one way to arrive at the choices.